Good afternoon. Let me introduce myself. I'm Nataliia Saichyshyna and I'm a master student of Kharkiv National University of Radio Electronics. The title of the research is Extension Multi30K Multimodal Dataset for Integrated Vision and Language Research in Ukrainian. In effect, this work would not be possible without a whole team of authors. They all are presented on the screen. Our group consists of students and teachers of Kharkiv National University of Radio Electronics. All this research has been going for more than 2 years, and we have many plans for its further development, but now we are ready to share our work and our results and explain some key points that relate to the study. The original idea was to create new solution using machine learning approaches for Ukrainian language. Our motivation increased because there are only small amount of data for Ukrainian language, which is the reason why Ukrainian language is considered to be a low-resource language for such studies. So available data may be limited, which can make it difficult to develop accurate and efficient models. This means there is practically limited opportunities to work with Ukrainian language in image captioning, text generation, and many other tasks. I should also mention the problem of machine translation, which is also not completely solved. Even if we use different tools to translate textual information from Ukrainian to English and vice versa, we face many inaccuracies. So first of all, I want to know that image processing and natural language processing are rapidly developing and relevant areas, and actually it confirms the importance of the work. Essential part of this work is to analyze the possibilities of using multimodal datasets. So multimodal datasets contain data in various formats, such as textual information, images, which are in correspondence with each other. The third goal of work is to find a way to increase the amount of data for Ukrainian language in order to be able to solve such tasks. For our study, we chose an existing dataset called Multi30K, a very popular one. Multi30K is a modification of the full Yerokhin dataset with more than 31,000 German translations of English annotations. This dataset was edited by professional translators, and one picture corresponds to one annotation in English and German. This dataset has also been repeatedly translated into languages such as French, Czech, Turkish. We consider it promising and useful and suitable for us in terms of size and content and topics it covers. Let's discuss the steps for preparing a dataset. To prepare this dataset for Ukrainian language, we first read and downloaded it. The next step was to translate it from English into Ukrainian using Google Translator. On this step, our data looks like this. I want to note that the results received from Google Translator served us as a basis for the next manual translation. This approach saved us time and allowed us to make changes with small edits. This step was accompanied by splitting the data into batches of several thousand. The next and the most important step was to manually correct Google translated data. Here we found and corrected lexical mistakes, grammar mistakes, and incorrect formatting. It's important to note that the corrections were made to fully match the English meaning and the image. During this work, we noticed many features of the data. For example, the inability of machine translation to work correctly with phrases in a figurative sense. So we fixed these cases and accept that training on our data will allow us to do it successfully. After preparing the dataset, we identified several tasks on which we wanted to test the practical application of the collected dataset. Among them were machine translation, that involves translation a source language image description into a target language. We published some results in our previous articles covering these topics, but here we want to extend some explanations and conclusions. Second task is multilingual multimodal semantic search. Is a task with a great demand, considered how much unstructured multimodal data is stored nowadays. So we need some methods to search it quickly, not only in English, but even in other low-resource languages. We wanted to check some available models with the support of Ukrainian language using samples from our translated version of Multi30K. And third task is usage of multimodal test embeddings model to measure translation quality, which should in theory allow us to check model performance without any target language, ground truth text. Some hard cases like phrases in a figurative sense should be considered to either prove or disprove the efficiency of this approach. The obtained data is suitable for work in the field of machine translation. We propose to use MT model. We have improved the quality of translation, but for more details, I would like to refer to the previous article. We have already presented in the article where Multi30K was a part of another dataset, so thus the dataset did not give us a big increase of performance, but improved the number of covered topics. So here you can see the values of the standard metrics for machine translation. We did a clustering of the received data in order to better familiarize with the results. To do this, we use CMS BERT and we perform topic modeling. So total we have 384 features. In this picture you can see that in the Ukrainian language we have more classes. That means that Ukrainian language is a morphologically rich language. So that is one word in English corresponds to many words in Ukrainian. Here you can see practical application of our datasets in the field of machine translation. So we examine the results with sharp visualizations, and here you can trace the influence of each particular word on its translation. We used a combination of CLIP and CMS XLMR in the result of our research on this topic. We can see that the English and Ukrainian descriptions quite clearly overlapped one by one. And however images fall in absolutely different part of this embedding space, they try to replicate the same form of those text clouds, but they are still far from text and don't really correspond to their descriptions judged by embeddings. Here is the example. The original description was young bearded man wearing a white tank top sits behind a drum set. The semantic search model returns a similar image, but with slightly different details. There is really a man with a beard who sits somewhere, but he just draws something on his table and there are no drums. However, the algorithm usually catches only subjects and actions, but misses all those small details like color and other objects. So we cannot recommend this approach, but we want to know that prepared dataset can be used for such purposes. It contains subjects and objects in a relatively simple location that perform different set of actions that can be later processed correctly. The next task I want to quickly cover is usage of multilingual text embedding models to measure translation quality. And here are some reasons why BERT score is not suitable for us during this research. So first of all, it requires a benchmark for the target language, which is missing in many cases. And BERT score uses multilingual BERT, which is not really very good for Ukrainian, so I reference the article prepared by our university. Normalization according to TF-IDF in a small sample can significantly change the score. It contains token-by-token comparison, so not at all text, and availability of state-of-the-art models for semantic search, which allow us to get a better comparison between text as a whole. Here I want to show a clear illustration with an example of how high the value of BERT score for sentences that do not have a common meaning and are not translation of each other. We also caught values that received a low score although they are translated correctly. The fact is these sentences are in a figurative sense or are phraseological units. Such cases are part of the prepared Multi30K datasets. This also makes it diverse and contains such examples. How do we work with this? We calculated cosine similarity between English and Ukrainian embedding vectors to check how an external model, for example, CMS XLMR as a student model and CLIP as a teacher model in sentence transformer implementation would score our fixed translations. The results obtained for some examples can be seen on the slide. This is our vision of the solutions to problem with phrases in indirect sense, which gave us impressive results. As a result, a Ukrainian version of well-known Multi30K dataset was prepared, which we applied for some tasks in the field of machine translation, multilingual multimodal semantic search, and proposed our method for assessing the quality of translations. So thank you organizers for the opportunity to present our work here.